Hi everyone. Today I will guide you through practicing econometrics using Stata software. Firstly, we will input data into Stata and we will have the database or dataset. That's one. In this case, we will estimate the regression effects of factors such as number of employees, cost marketing, or gender of CEO, or rubies on sales. We will observation on observe on 170 observation, 170 shots. We will use the common regression on Stata to estimate the relationships. We can use regression. Continue. We input the dependent variable. Example sale. Continue the independent variables. Uh, employee, employee, cost, marketing, and gender of CEO and province is the category variable. So we will have to record this variable. We can see this variable gender and province in character variables, so we have to record into numeric variable, and we can record such as record no I think we have encode gender CEO of source. We can generate the new variable. We can call gender. Okay, continue the province and cause the province and generate two new variable called name province as as and okay, we will run this command. Yes, we can see the new variables, gender and province. Yeah. So now we will regression with this variable. We add the new variable gender province is okay. And we can run this now and zoom in this window. Okay. Oh, employee not found. Maybe error in the typing. Employee. Yes, it's have P. Yeah, it's P. Okay. The results of regression on such a test. We can, however, we have to conduct some tests the model after we run regression. The first we have test multicollinearity. Yeah, multicollinearity. Yeah, multicollinearity refers to a situation in regression analysis where two or more independent variables are highly correlated with each other. This high correlation makes it difficult to determine the individual effect of each variable on the dependent variable, leading the unreliable estimates. We and we detect multicollinearity in Stata by VIS command after regression. Yeah, you can use VIF. Yeah, VIF. For instance, I will VIF after regression. Yeah, we can see the VIF value are almost less than 10. Yeah, yeah, yes. Where VIF's value greater than 10 are often indicates several multicollinearity. Yes, curious. Yes, when VIF value greater than 10, this is a serious problem in when we run regression. And solution to multicollinearity. The firstly, we can remove one of the correlated variables. We can combine a correlated variable into a single index. Yeah. And finally, we can use drive regression or PCA, yeah, principal component analysis. However, in this case, we can see the VIS almost less than 10, so there are not serious multicollinearity in this model. Uh, Continue, we have to consider heteroskedasticity. Heteroskedasticity. Heteroskedasticity occurs when the variance of the error term in a regression model is not constant across all levels of the independent variables. This violates one of the key assumptions of OLS regression, which assumes homoscedasticity, constant variance. How to detect heteroskedasticity in Stata? We can use BP test or Y test. So first we can consider the BP test. BP test we can use S stars has test. Yeah. After regression. Yeah. In this result, so the this model has a heteroskedasticity with the p-value equal 0, uh, less than alpha or alpha. If p-value less than alpha, uh, we reject null hypothesis. Yeah. P-value uh, we going use alpha with 5%, 5%. With reject, we will reject the null hypothesis. Null hypothesis. I will show it uh, null hypothesis. Homo, homo, homo Heteroskedasticity. Or in the Stata we can see null hypothesis, constant variance. Yeah, constant variance. We can retry constant variance. Yes. In this case, we reject null hypothesis, and we can see the model has heteroskedasticity. Besides, we can use y-test for general form. Y-test Y-test. Y-test is a popular test for heteroskedasticity in OLS regression. We can use the command as star im test white. Yeah, test white. We can see the p-value of white test less than 5%. So it's again so the model has heteroskedasticity. Yeah. So now when the model has heteroskedasticity, we have the correct this we can use robust standard error to correct heteroskedasticity. So first we can use robust standard error by we add the robust and regression. For instance, we can copy this regression and add robust and regression command. Yeah. Yes. In this way, we can see the beta. Beta is not change. However, the standard error will change. We can see the robust standard error is shown in this results. Yeah. Secondly, we can use weighted least square. Yes, we can use weighted least square. Yeah, OLS to correct heteroskedasticity. Or we can use yes. Finally, we can transformation the variable or function to correct heteroskedasticity. We can use apply log transformation to variable to reduce variance instability. Yeah. Transformation is apply log transformation to variable to reduce variance instability. Yeah. However, the simple way to correct heteroskedasticity is the first way. You can use robust standard error is the easy way and simple way to correct this. Yeah. And this result is the final result of regression after we corrected heteroskedasticity. And when we use result to analyze this, yeah, you can see with p-value less than alpha or 5%, we can decide that the employee uh, has significant, and with beta is greater than 0, so employee has a positive impact on sale. Yeah, and cost of marketing has a positive impact on sale too. However, gender and province insignificant. We can see the p value greater than 5%. However, we can see the gender of CEO and province is not a continuous variable, so we have you I to yeah, we have spares the gender are provised in regression to so uh, on of gender or province in this variable, and with this variable we have use common uh, we as I thought before this variable I thought, yeah, and we can see on gender on province in this variable. Uh, they are not different between male and female CEO. Um, they are not different among the province Hà Nội, Hồ Chí Minh, Huế, or Nghệ An. Yeah, you can see this variable is insignificant. Yeah. Oh, okay, right. My video is finished now. You can give the question in the comment, and I will answer, or I will create the new variable to answer your question. Thank you so much. See you next video. Bye bye.